What I'm going to do is go ahead and start out this part by creating a sketch on the top plane. This is just a rectangle centered on the origin to make it easier to do patterns and mirrors. And I'm going to use the structural command, the structural member command. There's a full library of all the shapes that are available for download. We have a separate video that shows that whole process. But you just choose how you want all the corners to be handled. In this case, I'm going to have the corners coped with the flanges pointing in. If I have any of the corners going in a different direction that I'd like them to have, simply click on that individual corner and override it. And now I have both of my end pieces going all the way through. A base flange feature with the exact same sketch gives me a nice flat platform on the bottom. I can split that up if I need to for manufacturing purposes. But the next thing I'll do is take that coped shape, just kind of reuse that coping shape to create a base flange in the middle of the part on the front plane. Use an edge flange at the bottom, set the material condition to material inside with no offset, and it's going to do a really nice job of creating that flange at the bottom that will allow me to connect to the bottom face and no gap in that. Now, we can obviously create manufacturing tolerances as needed. We'll address that once we get to the simulation too. Locate a couple of through holes. These are just clearance holes to reduce weight, but also allow for the flow of concrete inside this platform frame. The cut is linked to thickness. That way it's only going to cut through one thickness of the part. Set up my spacing on these whole pattern, but to get the end condition to just stop cutting once it gets to the end, we'll just say up to reference. Now, this is a multi-body part. So this is not an assembly. So when you do a pattern, instead of doing a component pattern at the assembly level, I'll simply do a body pattern at the part level. Pattern seed only, and now instead of one, I have 5 of these internal structural supports. I'll draw a line for a stabilizer. The stabilizer arm is just going to be a bar or maybe a pipe or something like that to kind of connect the sides and keep these thin flanges from falling over. So again, I'll go back to my structural member command. Now, this could be an extruded boss, but by using the structural member command, I'll be taking advantage of things like automatic length and also the ability to do trims. Now, I built this a little high, so I'm just kind of cheating here, and I just pushed it down a couple inches, very much like you might do inside of an assembly if you place something too high. And then I'll do 2 things. I'm going to do a cut, and the cut is going to be for all the sheet metal bodies. Now, I could use the cut on the weldments as well, but I don't want to actually cut through those. I want to butt it up against the inside of that structural member. So we'll cut all the way through, set the scope of the feature so it only cuts those sheet metal parts in the middle, and then I'll just do a pattern of that whole piece. Before I do that, I'll go ahead and trim that pipe to length so it stops at the thickness of the inside of that flange. Do a pattern, we'll do 5 sets of holes all the way through. Looks like it accidentally cut more bodies than I was hoping. So I'll just do a quick couple of adjustments on the depth of that cut, location of the plane. These are all standard SolidWorks functions, but now I can go ahead and pattern that bar, again with a body pattern, just like I did with those sheet metal parts, and that's going to give me those 5 internal supports that I need. Now we're getting pretty close to the finished part, so I'll give it a save. I do want to make it a little shorter, made it a little longer initially than I needed to, because this is all parametric, because those end conditions on the patterns are all up to reference and things like that. It's going to automatically adjust very easily. To create my drawing, this is actually just a part file, but it builds a drawing very much like an assembly file. Instead of doing a bill of materials, or if I want to, I can, it'll also have the ability to do a cut list. And each item that's the same is going to be given multiple quantities, and they'll just show up just like a balloon would. Give it some quantity markers here at the balloons if I want to. Just going to change a few things to make it look nice, but pretty much all the same rules would apply here. Now, another thing is this part has some sheet metal in it, and I need flat patterns. So I got a couple ways I can do it. Quick right click at the assembly level or at the part level, and I can export to a 1-to-1 DXF or DWG. For this flat pattern, I also created a flat pattern on the drawing so you could see it. I had to roll back to finish that design up, but there you see there's the flat pattern, so I can detail it out so that even though it's a multi-body part, the whole thing is one big part, It's still very simple and easy to document each individual piece as needed. Now, once I go into simulation, there's a couple things here that are going to be different because I built these with structural members and sheet metal. All the welded beams that are done with the structural member command are going to come in as beam meshes, which are basically sticks where the moment of inertia, or the cross-sectional moment of inertia, will be taken into account automatically. I can use those joints at the corners to set up my fixtures. Now this is a pretty cursory, simplified, model, and so where I can say the joints are withheld or fixed so that it's not moving, maybe I need to do something a little bit more accurate later on down the line with a solid mesh. But for a first run, it does a really nice job, especially for things like sizing out the beams to make sure the beams are going to be big enough. When I create my mesh, create my fixtures, and run this first study, you're going to see the results. Again, we'll kind of have that beam and shell thickness look to it. So just going to take a second to get those results, and then we just got to make sure everything's going to be connected up right. I have a global bonded contact, and that global bonded contact for all touching faces is going to kind of act like it's all welded together. For the beams and meshes, your stress plots are going to be separate, but your displacement plot will show both. And in this case, the pipes didn't bond to those sheet metal pieces, and so did the channels. So we'll go through and create contact sets between the beam and those sheet metal flanges, and another set of contacts between the ends of those sheet metal flanges and the C channels. So little cleanup to be done here, but this is possible or true in a lot of other types of meshes, whether you're doing beams or solids. Just got a little bit of work to do to make sure everything's where you want it. Tell it to render that in 3D and tell it to show the mesh, and it does a nice job of giving me what I need, which is just a really simple, quick run, no horrible aspect ratio parts. It's going to mesh easily and quickly. Now for contrast, we're going to flip it around. We're going to do this with a solid. Now I'm not going to run this all the way through. That'll be an exercise for another video. However, what you may see is we're going to end up with different aspect ratios, and we're going to end up with some difficulties doing the mesh. You can override it, whether it was made with or without a structural member. You can still tell it to treat it as a beam or treat it as a shell or a solid, and kind of override that material or that mesh type. Bring over the force and kind of get it all set up. And when I do the mesh, you're going to see that the standard parameters for the mesh are, for the minimum size on that mesh, to be like 1.5 inches, even though these are core-inch flanges. And so you're going to see mesh failures. It's not going to be too uncommon to see the mesh fail completely, or just on certain bodies. You can turn off the compatible mesh option. That might help. You can change the mesh size, but it's not going to be quite as straightforward as using beams and shells using sheet metal and structural members. So that's how you'll approach a model like this, at least getting started for building this kind of a design for analysis specifically.